Hey guys, so today we're going to see the rotting oranges problem. It is problem number 994 in LeetCode. Although it is tagged as an easy problem, it is sort of a medium problem, and this problem is asked in most of the big companies, especially in Amazon, and you will encounter different versions of this problem. Sometimes it will be asked just like the rotting oranges problem, and sometimes it will be asked in the form of zombies in a matrix problem. So both solutions is just the same, so once you identify the pattern, it is easy to apply the Trojan solution. So let's read the description and let's code this later. Okay, so the description says that in a given grid, each cell can have one of three values: value 0 representing an empty cell, value 1 representing a fresh orange, and value 2 representing a rotten orange. Every minute, any fresh orange that is adjacent, forward directionally, to a rotten orange becomes rotten. Return the minimum number of minutes that must elapse until no cell has a fresh orange. If this is impossible, return -1 instead. So let's look at the example. Okay, so example C, in 0, 0 you have got a rotten orange, right, marked by the cross. So at minute 1, what happens is this rotten orange has two adjacent fresh oranges, right? There is one adjacent fresh orange to the right, and there is one fresh orange to the down. Okay, so at minute 1, it goes ahead and makes those two oranges rotten. Now we've got 3 rotten oranges, and now we've got 4 fresh oranges. Okay, at minute 2, what happens is this particular rotten orange goes ahead and makes this fresh orange, which is earlier fresh, right, rotten, and also it goes ahead and makes this rotten. And now since these two are rotten, this has no other way to rot any other oranges, because it just has an empty cell beneath. Okay, so at minute 2, we've got only 2 fresh oranges. At minute 3, this particular rotten orange, the newly rotten orange, it goes ahead and rots this orange. Now at minute 3, you have got only 1 fresh orange left. At minute 4, what happens is this again goes ahead and rots this orange. So at minute 4, we've got every orange rotten. So the number of fresh oranges here is 0. So all the oranges were rotten, so the number of time taken to rot all oranges was time 4. 4 minutes was taken. So the output is 4. As said in the description, 2 means a rotten orange, okay, and 0 means empty cell. Okay, let's look at example 2. 211, a representation is not given. 0, 211, 011, 101. Let's do this. Okay, so we've got 2 1 1, 0 1 1, and 1 0 1. So at minute 1, what happens is this particular rotten orange can rot this adjacent fresh orange. This is a fresh orange, so it can rot this, right? So at minute 1, we've got 1 rotten orange, 1 new rotten orange. Okay, so there are 2 rotten oranges. So the representation is 2 2 1, and 0 1 1, and 1 0 1. Okay, now at minute 2, what happens is this can go ahead and rot this, right? But these are all fresh oranges, so we've got 3 rotten oranges at minute 2. So 2 2 and 2, and this can also go ahead and rot this fresh orange, right? So it 4 actually. Yeah, so we've got this rotten orange, it can go ahead and rot this. We can move left, we can move down, we can move right, and we can move up. There are 4 directions. right? There are 4 directions. The description says 4 directional. So which means 2 2 2 and 0 2 and 1. Okay, 1 0 1. This is because this is not an adjacent neighbor of this 2. Okay, so at minute 2 we've got 4 rotten oranges. Now this can go ahead and rot this, and this can go ahead and rot this, because here you have got an empty cell, and this cannot go ahead and rot fresh orange diagonally. So we'll have 2 2 2 and then 0 2 2 and then 1 0 1. Okay, so at minute 3 we have got 5 rotten oranges. Okay, this has gone ahead, these 2 can go ahead and rot only this. Okay, that's why. So now what happens at minute 4? Okay, at minute 4 this cannot go ahead and rot anything, and this cannot go ahead and rot anything here, whereas this can go ahead and rot this particular orange, fresh orange here. So we'll have 6 rotten oranges. So the representation is 2 2 2 and 0 2 2 and then 1 0 2. Now if you see, we've got an empty slot here, so 2 cannot actually go ahead and rot this diagonally, and we have in fact no other rotten oranges can go ahead and rot other oranges. Basically this fresh orange will remain fresh, right? So which means that you cannot rot all the fresh oranges, so output has to be -1, because we have to return -1 if we cannot have rotten oranges all over. Okay, so that's why for example 2 output is -1. Okay, that's because orange in the bottom left corner, row 2 column 0, yeah, this is fresh, this is never rotten. Okay, and let's take a look at example 3. So if you have an input of 0, 2, here we do not even have fresh oranges, so we need not even bother about going ahead and rotting fresh oranges, so we have to return 0 because there are no fresh oranges at all. Okay, so let's discuss about how can we solve this problem. Yeah, so as you can see, every time we are moving in steps, right? Every time we have to see whether there is a particular rotten orange, and then accordingly we go ahead and basically rot the adjacent oranges. So for every rotten orange, one thing is fixed: for every rotten orange we are going in 4 directions: right, down, left and up. So we are going in 4 directions, and every rotten orange that we are discovering, like for example at minute 1 what we did, we went ahead and made this orange rotten, and then that becomes added to the list of rotten oranges, and then we went ahead and made this fresh orange rotten, and that becomes added to the list of rotten oranges. Then we have got some 4 fresh oranges. Number of fresh oranges were not 0, so we were going ahead and making each one of them rotten based upon the 4 adjacent directions. And finally, when the number of fresh oranges was 0, then we returned the number of elapsed time, that was actually minute 4. So the output is 4. In this case, what we did was we went ahead and did the same thing for every rotten orange. We went ahead in all 4 directions trying to make other oranges rotten, but at a particular point of time we see that we cannot rot any other oranges further, so which means we return -1. And in this case, in example 3, what we did was we saw that the number of fresh oranges is 0, so which means we need not even go ahead and solve this problem. So what we can do is, okay, we have to keep a track of the number of oranges. We have to keep track of the number of fresh oranges, because the fresh oranges count is used to determine whether we should return immediately. If there are no fresh oranges, we should return immediately, and if fresh oranges have become 0, then we have returned then we have actually attained a solution. Okay, so the number of fresh oranges plays an important count here. So how do we go ahead and add each one of them? So basically, if you see, this is like first in first out, right? The first rotten orange goes ahead and rots certain oranges, and these two were the rotten oranges, and then we pop one of this, we take one of these and try to rot other oranges. So if you see, everything is first in first come first served basis. So we need to use a queue to basically keep track of the rotten oranges, and we need to keep track of the number of fresh oranges. Okay, and then we will have to explore in all four directions. So the approach is quite simple. The approach is just an extension of our basic intuition when you get this problem. Okay, so what we will do is, let's have int fresh orange count. Okay, int fresh orange count, this is equal to 0. So what I'm going to do is, let's iterate over the grid. Row is equal to 0, row is less than grid dot length, and then row plus plus for int column equal to 0, and column is less than the number of columns in the grid, and call plus plus. So 2 means it's a rotten orange, right? So if grid, so we need to keep track of all rotten oranges in a queue, because we are processing all rotten oranges in a first come first go basis. So I'm going to have a queue. It is going to be a list of 2 element integer arrays, basically representing a point, right? Because we can represent this cell in the form of x comma y, which is actually a 2-dimensional element. I'm going to have it as a queue of 2 element integer arrays. I'm going to call this as queue equals new linked list. Okay, so now if grid of row column, this is equal to 2, this means we have to add it to our queue. This is a rotten orange, right? So queue dot add or offer, whatever you can use, add or offer new int, and then let's add row comma column. Okay, else if grid of row column, if this is equal to 1, this means it's a fresh orange, right? So let's increment the number of fresh orange count. Okay, so now as per example 3, if the number of fresh oranges is 0, which means we need not do anything, so we have to return 0, right? There is no way we can go ahead and rot any empty fresh oranges, right? So fresh orange count equal to 0, then you return 0. Okay, now while queue is not empty, which is intuitively it follows, right? So while we do not have any other rotten oranges, is empty. Okay, so what is the number of rotten oranges currently? So for each rotten orange, we have to basically explore all 4 directions. So let's quickly get the size of the rotten oranges. So that is q dot size. Now for int index is equal to 0, index is less than size, and index plus plus, let's take point equals q dot o. Let's take this, and we need to have 4 directions, right? So let's quickly initialize a directions array. So here what happens is, let's take the clockwise approach. In the clockwise approach, you will move and right and then down, and then you will move left and then go up. Okay, you will move it like this, right? So when you move towards the right, then j will increment, I remains the same, so 0, 1. Okay, when you move down, I will increment, j remains the same, and when you move left, I remains the same, but j becomes -1, j decrements by 1. When you move up, I actually decrements by 1 and j remains the same. Okay, so now we've got a rotten orange. This point is actually representing a rotten orange. Now for every directions, so let's go for int there in this directions array. So int x, let's get a new direction, new cell basically. Okay, so this is going to be point of 0 plus direction of 0. So this is going to be our x coordinate, and int y is going to be point of 1 plus direction of 1. This is going to be a y coordinate. Now we have to make sure that we are not actually going out of bounds, right? So we need to check whether x and y are within bounds. So if x is less than 0, or x is greater than or equal to grid dot length, or y is less than 0, or y is greater than or equal to grid of 0 dot length, this should be less than the number of columns. Okay, or grid of x comma y. We should not be actually going ahead and marking an empty cell as rotten, so this should not be equal to 2, right? We cannot go ahead and have mark a rotten orange as rotten, because it's already rotten. We cannot make it rotten again. Grid of x and y, if this is equal to 1, this is an empty cell, so we can't do anything. In these cases, what we will do is we'll continue, so we'll just go ahead and pick the next x and y. Now once we have come out of this, this means that the current grid element is a fresh orange. So if it is a fresh orange, let's rot it. Grid of x of y equals 2. So we have rotten it, so which means you have to reduce the number of fresh orange count. So fresh orange count has to be reduced. Okay, and if you see, we have to keep track of the time as well, right? So for that, let's keep track of the time using elapsed time equals 0. At the start, let's, whenever we are taking it, elapsed time, we'll increment this. Okay, so now return if this fresh orange count, if this is equal to 0, this means you have rotten all oranges. In that case, what you can do is you can return elapsed time -1, because we are incrementing it at the first. If not, we have to return -1. Okay, and since we have forgotten to do one thing, since we have made this rotten orange, we have made this fresh orange as rotten, we have to add it to the queue, right? So we will add it to the queue dot offer of new int x comma y. Because we have made this as rotten, we will go ahead and add it to the queue. Okay, I hope it was clear. Let's quickly run this code. Wrong answer, -1. Why? elapsed time is plus plus, you're taking the queue size, index is less than queue size, you're taking the point of 0 plus direction 0. And if this is if it is, oh, this should be 0, guys. If it is an empty cell, then we need to continue. Yeah, okay, let's run this. Yes, it's accepted. Let's submit this. Yes, and it's a successful submission. Okay, I hope it was clear. Comment below. Please like this video. Bye.